If we were to add up all the mass of every person, house, planet, and galaxy in the universe, we would only end up with about 5% of the universe's total mass. So where is the other 95%? Well, physicists and astronomers theorize that the remaining mass of the universe is taken up by two things: dark matter and dark energy. Dark matter takes up about 27% of the universe's mass, while dark energy takes up the remaining 68%. So what is dark energy, and why does it occupy most of our universe? Well, to understand dark energy, I'm going to have to take you back, way back, to approximately 13.8 billion years ago, to the origin of our universe, the Big Bang. Ever since then, our universe has been expanding, and about 4 billion years ago, the expansion rate began to accelerate. Up until the 20th century, the universe's rate of expansion was actually thought to be slowing down. However, we are able to prove the opposite through the Doppler effect and red shift. The Doppler effect states that the frequency of a wave changes as it moves either further from or closer to an observer. As the source of the wavelength approaches a shorter distance, its wavelength is shorter and has a higher frequency. Vice versa, when the source is further away, its wavelength is longer and has a lower frequency. Think of it like this. When you hear an ambulance approaching you, the pitch of the sirens becomes much higher, i.e., having a shorter wavelength and a higher frequency. When the ambulance is moving away from you, the pitch lowers, showing you its low frequency due to a longer wavelength. With light waves, we are able to see the same effect in outer space. Short visible light waves present a bluish color, so galaxies and stars closer to us emit a blue hue. Longer and therefore further away light waves emit a red hue. When observing distant galaxies, it was determined the light waves emitted from these distant galaxies were so much further to the red extreme of the visible light spectrum that they must be moving away from the Milky Way galaxy. This is known as the red shift. So, what does this have to do with dark energy? Well, dark energy is the cause of the acceleration of the expansion of the universe. In this case, dark rather means unknown, not actually dark, because, well, we don't know that much about it. We do know, however, that the total amount of dark energy increases as the volume of the universe increases with time. So as the universe expands, the volume of dark energy increases. And that dark energy should be thought of as a property of space that keeps pushing galaxies further away from each other. So what don't we know? Well, pretty much everything else. But that's what makes the future of science so exciting.